always be accessible to the child class, and if not accessible, inheritance will not be possible at all. Okay, this is the first important rule of inheritance. The second rule, child classes can consume the members of parent class, but parent classes cannot consume any members that are purely defined in the child class. It's not possible. What is that? Child classes cannot consume the members of parent class, but parent classes cannot consume any members that are purely defined in the child class. What's it? In inheritance, the parent class cannot access the child class members, man. I already said you, in law, it's law. What is it? Parents don't have right on the children's property. Parents don't have right on the children's property, but children have right on the parents' property. The same thing. So the parents doesn't have any right on the children's property here. So the parent class members are accessible to child, but child class members are not accessible to parent. This is rule number 2. Okay. Rule number 3. Guys, in rule number 3, we have again 3 subpoints. In rule number 3, we have 3 subpoints again. Okay. So I'll say like 3.1. What is this? First point. Actually, we have 3 things here, man. All the 3 comes under rule number 3 only. Okay, now? So let me explain you. Just like we can create the reference of a class by using the, remember this? It's a old story. We already learned it. You can initialize a variable of a class by using instance of the same class. Okay? Just like we can create we can create the reference of a class by using the instance of same class. We can also create the reference of a parent class by using instance. What is this? Look, man. Class 2 obj1 is equals to new class 2. Sorry. Okay, now. Then the next line, can I say class 2 obj2 is equals to obj1 or not? Open the mouth here. We learned it already now. This is an old story, nothing new now. What is it? You can initialize the variable of a class by using the instance of the same class now. It's a very old story. Now, what is the new thing? Watch. Class 1 obj3 is equals to obj2 is also valid. Did you understand or not? You can initialize a parent class variable also by using a child class instance. By using a child class instance. Okay, sorry guys. Sorry. By using a child class. What is obj1? Instance of child class. Don't say class 1, class 2. Last class I said your parent child. Tell that. What is obj1? Instance of child class. What is obj2 initially? Variable of child class. It is a variable. And you made it a reference now. Array. What is obj2? Variable of child class is equals to obj1. Reference of child class. Again, same. What is it? Variable of parent class, right? You can make it as a reference. We can make it as a reference means here obj2 is initialized. Here also obj3 is initialized. Okay, so this is old one, guys. This is a new one. Read the point again. Okay, I'll write in another way. Just like we can not create, we can initialize the variable of a class by using the instance of same class. We can also initialize the variable of a parent class by using, this will be more accurate now. See, read again. Just like we can initialize the variable of a class by using the instance of same class. This is what we learned in the last week, man. What is the new point? Variable of a parent class by using child class instance. Okay. So from now, the parent reference also starts consuming the both will access the same memory now. Watch this picture. Last class I shown you, I shown you this, remember? What you created? Child class instance. When you create the child class instance, I said you, it will contain the information of class 1 and class 2 now. Now see, this is a new thing. Now there is a reference here. Both are accessing the same memory. Both are accessing the same memory. Maybe names are different, that's all. I given OBJ1, OBJ2, here I said CP something. That's all. Just a minute, I will show you in the code directly, so it will be much better for you to understand. Look, guys. Class 2C is equals to new. What is C? Instance of child class. Whenever you create the instance internally, this is what happens now. Yesterday I taught you. Are you clear? What are you doing now? Is equals to C. Now see, this P is also accessing the same memory only. That's what I'm trying to tell you. We learned it already now. Both P and C will be consuming the same memory. Are you clear? Now tell me, using P, can I call the members of class 2 now? Using P, can I call the members of class 2 now? No. The rule is rule. What I taught you yesterday. Parent cannot access pure child class members. And now also the rule is same now. You cannot consume. You cannot consume. But now also, using the parent class reference, it will not be possible to call any pure child class members. See, look, this is accessing the same memory, no doubt. But with this P, you cannot call the class 2 members. Watch this picture. I don't see any expression on the face. Understood? Why to create? That is secondary. I said you, I'll tell you where to use. See, last week when I said you about the references, we don't know what is the use of it until we understood about the ATM case study. For everything, there is a need. There is a reason. We'll talk about it. What I'm telling you, when I say something, stick to that only. Don't go beyond. Where to use, I'll tell you. Are you getting me or not? So what is the rule? What is the thing we learn? We can initialize parent class variables by using child class instance and make it as a reference. From now, that reference will be consuming the child class memory, but with that it is not possible to call pure child class member. The rule is rule. Say your parents are living in your house. Your parents are living in your house. Are you getting me? Because they are living in your house, they don't have a right to sell your house there. As what I said to you yesterday, child has a right on parent property, but a parent doesn't have a right on children's property. It is a responsibility of the children to take care of your parents. It is your responsibility to take care of your parents now. So they're living in your house now. They're from some village. You settled in Hyderabad. Now you brought them and put in your house now. Because you put in your house now, they can use that house, but they cannot sell that house. Are you guys clear or not? Understood my point? Okay. So that is what the point you just require to remember. See, tomorrow, in any unfortunate situations, if the parents got expired, all the children should sign on that to sell a property. Are you getting me? See, there is a property on the parent's name. Unfortunately, the parents got expired. Now the children wants to sell. Everyone has to sign now. Because all children have the right. But their parents doesn't require to sign on that. Got it or not? Your grandparents doesn't require to sign on the document now. Why? They don't have any right. Who has the right? Children have the right, but not the parents. Are you clear? So this is something like you're bringing your parents, and they're living with you in your house now. But because they're living in your house, they don't have a right to sell that house. Are you clear? Now also same I'm telling you. Using P, you cannot call class 2 members. Are you clearer or not? Understood? Because see, this third rule, I have said you 3 points are there now. These 3 are very, very important here. Not only today, until the end of our .NET, not C#, until the end of our .NET, we'll come across these points everywhere. Not just today, until the end of the .NET course, we will come across this in some situation. That is why I'm stressing a lot on each and every point. Am I clearer? Any doubts on this? Once again, you can read the rule number 3. Just a minute. What did you write? Tell me that. Then I can tell you the problem. Yeah, all of you can read. I'm highlighting that any pure child class members are not accessible. See, I said you that only pictures will describe you much better. That's why I'm showing you a picture for everything now. See, this is the first scenario. Child instance created will contain the information of both now. Second picture. The parent is also consuming the same memory now. Third picture. Parent cannot look into the child. Parent cannot look into the child. Is that clear, everyone? Yeah, look, man. Now 3.2. We cannot initialize. Child class variables by using parent class instance. Reverse is not possible here. What is that on the top? We can initialize parent variables by child instance. Correct now? Now I'm telling you reverse. Reverse is not possible. Read that. We cannot initialize child class variables by using parent class instances. Reverse is not possible. Either implicitly or explicitly also. I hope you remember these two words. I explained you already about implicit and explicit. What is implicit? If you do a direct assignment, that is called as implicit. If you do some conversion, that is called as explicit. Now tell me here, did you do implicit assignment or not? Come on, answer me. Yeah, implicit. What is explicit? Some conversion. Some conversion is called explicit. So here I'm telling you, implicitly also not possible, explicitly also not possible. Let me show you practically, you'll understand now. Watch it. Yeah, I said you know, using P, I cannot call child class members now. I'll prove you, see. Test 1, test 2 can be called here because these two are parent class members only. Test 1, test 2 can be called because these two are parent class members only. Okay, but you cannot call 3 and 4C. Error coming there. Why? Pure child class members not accessible to parent. Okay. Now I want to show you the reverse. Come on, tell me what is P? Instance of parent class. Instance parent class. What is C? Variable, not instance. Variable of child class, not initialized. Correct now? And I want to initialize it by assigning P now. Are you clear? I want to initialize by P. See their error. That only I said you. What is it? Parent class reference instances cannot be used for initializing child class variables. What is possible? Child to parent is possible, but parent to child is not possible. See their error. Okay. I use the word there called as implicitly or explicitly. Correct now? Why I use the word, I'll tell you. Tomorrow, when you guys are reading this error, it will show you that message like that here. What is it showing you? Are we done a direct assignment only now? Direct assignment is implicit now. See, telling you, see, cannot implicitly convert class 1 to class 2. Are you clear? And afterwards, there is a question here. What is the question? Verify yourself if there is any explicit conversion possible. Verify yourself if there is any explicit conversion possible. But what is it telling you clearly? Implicit conversion is not possible. Explicit, I don't know. Why you don't know? Because these are user-defined classes here. If it is a predefined class, compiler will tell you right or wrong. But these are predefined classes, user-defined classes. Then how will compiler know that? Did you understand the question or not? These classes are not predefined. These classes are user-defined. So compiler doesn't know any information about this class now. Are you getting me or not? Compiler don't know any information about these classes now. It's predefined. It's a user-defined. Compiler is not aware of it now. I hope you guys are following me. Yes or not? That is why I'm telling you. What is it? Implicit it said you, but explicit it is not known because these are my class. This is my class, not a compiler. Predefined class now. But we're checking. You verify yourself if there is a explicit conversion is possible or not. So explicit conversion means using some conversion mechanism. Do you remember? Yes or not? How do I do it, sir? Remember this? We learned about as operator, na type conversion. Is operator, type comparison, as operator, type conversion. You see, you're trying to convert P as class 2. It's not valid. You can't do that. That is explicit conversion, man. That is another way you can write this. Typecasting. What is that? Typecasting. Explicit conversion. Both are explicit conversions only. Error C. Error. You can't do that. You cannot do that. Are you clear? Okay. So now, come on. Once again, you can read this point. Did you understand why I used the word implicit and explicit? If you do a direct assignment, that is implicit, not possible. You're trying to do a conversion, that is also not possible. Implicitly also not possible, explicitly also not possible. Okay. So listen, all of you. Very simple here. I did not tell anything great. Very simple thing I said here. Watch. I have a child instance. With this, I can create a. That is what I said to you in the first point now. I have a parent instance. Using this, I want to create a child reference. And this is valid and this is invalid. That's all. Telling in simple words. Are you clearer? The first one is 3.1 and the second one is 3.2. For the first rule, child instance to parent creation, parent reference possible, but parent instance to child reference is not possible. But guys, this is possible or not? Tell me. This is possible or not? Tell me. What is it? I have a child instance. With this, I created a. Now, with this, can I create a child reference again? Will you answer today or shall we meet tomorrow again? Make it fast here. I'm waiting for you and you are putting blank faces. Come on, what are you thinking? Valida, invalida? Valid, yeah. I said you a similar concept to you. You don't remember anything. Value types can be converted to reference types. Yes or not? Reference types cannot be converted to value types. Correct? A value type converted to reference type can be converted back to value type. Where you started ending there only, na? Where you started? Where you ending? Child only, na? What is the problem then? Am I clearer or not? See, child first converted to parent. Parent to child again possible. This is the same concept I taught you earlier. See, I have a value type. Can I convert this into reference type? Yes, possible. Yes, possible. This is valid. I have a reference type. Can I convert this into value type? No. It's invalid. But see, I have a value type converted into reference type, can be converted back into, and this is valid. And do you have to remember the terminology here? This is called boxing and this is called unboxing. And this is called as unboxing. But the middle one is not possible. Related, both are looking same now. Relate, I'm 1 and 2. See now, both are looking same. What? Child to parent, valid. Parent to child, not valid. Child to parent, back to child, valid again. Are you guys clear or not? Understood all of you? What is possible? Child to parent, back to child is possible. That is only 3.3 is. What is that, you know? A parent class reference, which is created by child classes instance, can be used to initialize a child class variable. Initialize a child class variable by performing, by explicit conversion. Now also implicit is not possible. What should I do? Explicit. Okay. Now I will show you in detail. Answer. Watch carefully. What are you doing? Louder. Created instance of child class. Correct now? Created a reference of parent class using child class instance. Okay now? You created a reference of the child class by using a reference of the parent class, which is initialized by child instance. See, child to parent back to child again now. But what I said you, explicit is not possible. Compulsory, sorry, implicit is not possible. Compulsory, explicit means you cannot directly say this is not possible. How to write? Class 2 of P. Other way of writing this code is yes, class 2. Understood? Once again, I'm telling you, this is what I said you in 3.1. Describe it. Describe it. We can create a parent class reference by using child class instance. Simple. We can create a parent class reference by using child class instance. This is 3.2. We cannot create a child class reference by using parent class instance. That is cannot create. First one is can create, second one is cannot create. Third point. We can create a child class reference by using parent class reference, which is created by child class instance, which is created by child class instance. Now tell me, does OBJ will have a separate memory, will be consuming the same memory of C? Same memory, man. All these three are consuming the same memory only. Watch the picture. Are you clear? All are accessing the same memory. Using OBJ, can I call the members of class 2? Answer fast. Using OBJ, can I call the members of class 2? Can I call the members of class 1? Yes. Simple here. You can look straight, you can look top, but you cannot look in the bottom. I repeat my statement again. Watch it. You can look straight, you can look top, but you cannot look in the bottom. Understood or not? Come on, standard P, look straight. What do you have? Class 1, accessible. Okay, standard C, look straight. Look top. But standard P, look bottom, not possible. Not possible now. Are you clear? And that's why, see, this OBJ is again pointing here only. Means I can look into the top now. What is not possible tomorrow if class 2 as a child class, class 2 as a, I cannot call them by using C also, OBJ also. P only, C and OBJ also are not called. Okay. So simple thing you remember. I can always look straight. I can look in the top. You're standing on the road. You're standing on the road. I'm asking what is present for you. You'll say. Until the right side visible, you'll say what is present. Look at the sky now. What is present? The clouds, moon, star, sun, whatever it is. If any flight is going there, whatever you see, you'll say. You're standing on the road and say, look down and tell what is inside the earth now. You can't look now. Yes or not? Same only I'm telling you. You can look straight, you can look top, but you cannot look in the bottom direction. The bottom direction looking is not possible. That is what exactly you guys require to remember and understand. Am I clearer or not? Understood all of you? So this is what exactly the third law of inheritance is all about. So totally 3 points. And simple way you remember these three, it is easy to understand the 3 points now. Okay, once again, what is the first point? Describe it. We can create a parent class reference by using child class instance. Second point, we cannot create a child class reference by using a parent instance. Third point, we can create a child class reference by using parent class reference that is created by child to parent back to child again. Where you started, you're ending there only now. No confusions in this context. Am I clear? Okay. Now look at this. Look at this. Sorry. Using P, I cannot call the child class members now. Yes or not? But just answer me. Using P, can I call the members of the parent class? Can I call the members of the parent class if present for class 1? Answer me. If class 1 has a parent class, using P, can I call the members? Possible or not possible? Possible now? Okay. Now my second question is class 1 having any parent class? Is class 1 having any parent class? Yes or no? Confidently. Wrong answer. Yes. Sir, I did not inherit. No need to inherit. This is a very, very important question in trios, remember. There is a default parent class for all the classes. There is a default parent class for all the classes. Which class, you know? Object class. Which class? Object is a default parent class for all the classes, which is directly or indirectly inherited for all. Which is directly or indirectly inherited for all. What is that, sir? Directly inherited, indirectly inherited, confusing? I'll tell you. Look at this, guys. You're defining a class here. What's the name? Are you inheriting this class from any other class? Tell me. Are you inheriting this class from any other class? No, na? No, na? Compiler will automatically inherit from object now. Compiler will automatically inherit from object. So class 1's parent class is object now. Okay, now come to class 2. Are you inheriting this class from any other class? Which class? Then no need to inherit from object then. That automatically a parent, grandparent. Then class 1 is a parent of class 2. Object is also a parent now. Grandparent. Are you clearer or not? So that is what I'm telling you. Directly or indirectly, every class should inherit from object. You know one thing? Object is a root. Object is the root. Maybe it's a predefined class or maybe it's a user-defined class. All of them will inherit from object. Did you understand or not? Maybe it is a parent or, sorry, maybe it's a predefined or user-defined. Every class will inherit from object. That is the super parent. Clear? And that only thousands of classes defined by thousands of programmers in their life cycle, means from the last 22 years, are present. I don't say thousands, millions of classes.